Have you ever truly looked up at the night sky, lost in its profound beauty, past the city lights that often obscure our view, and wondered about the endless stars stretching out into the inky blackness? Each tiny pinprick of light holds a universe of possibilities. Each star is a sun, a blazing inferno of energy, many with their own planets, swirling around them in a cosmic dance all within our Milky Way, a vast island of stars, just one of billions of galaxies, each a universe unto itself. This vastness, this almost incomprehensible scale, leads to a profound question, one that has haunted humanity for centuries. Is the universe infinite, stretching on forever, or does it have an edge, a boundary beyond which nothing exists? The answer to this question could fundamentally change everything we know about reality, our understanding of physics, and our place within the grand cosmic tapestry. If infinite, then every possibility, no matter how improbable, could play out somewhere within its boundless expanse. Maybe even another you, living a different life, making different choices, on a planet mirroring our own. If finite, what lies beyond that ultimate barrier? Does the universe loop back on itself, curving in on itself like some gigantic sphere? Or is there a true boundary, a cosmic wall marking the end of everything we know? Our planet is but a tiny boat, adrift in a cosmic ocean of unimaginable size, and our horizon, the furthest we can see, is merely the edge of the observable universe, a tiny fraction of what might actually exist. With telescopes, both on Earth and in space, and mathematics, the language of the universe, we chart the unknown, pushing the boundaries of our knowledge, mapping the biggest mystery of all, everything, the entirety of existence. This journey, this quest for understanding, is a testament to the insatiable human curiosity that drives us to explore, to question, and to discover. So, let's embark together on this incredible adventure, starting with what infinite truly means in a cosmic sense and the implications it holds for our universe. We'll explore clues from the universe's very birth, the echoes of the Big Bang to the way galaxies are scattered across the vast expanse of space, forming a cosmic web. We'll examine leading theories, the cutting edge of cosmological thought, the evidence that supports them, and the challenges we face in unraveling this profound mystery, in finding a definitive answer to the grandest question of all. Fasten your seatbelts, prepare for the unknown. The universe in all its infinite or finite glory is waiting to be explored. In cosmology, the term infinite carries a very specific meaning. It doesn't just mean really, really big. In the context of the universe, infinite means that space itself goes on forever, extending without any spatial limit. There's no edge, no boundary, and no outside to it. It simply continues endlessly. It's a concept that's profoundly hard to grasp, precisely because everything we experience in our daily lives has boundaries. Our homes, our cities, even our planet, all have defined limits. To try and visualize this, imagine being an ant on an endless sheet of paper. You could walk in any direction, for any length of time, and you would never, ever reach an edge. The paper extends infinitely in all directions. That's analogous to a spatially infinite universe, unboundedly big without any end. However, it's crucial to understand that a finite universe doesn't always have an edge either. This is where things get even more interesting. Think of the surface of a balloon. The surface itself is finite, meaning there's a limited amount of area, but you can walk around it endlessly and never fall off, because there's no edge to the surface. This concept is known as finite but unbounded. It's finite in size but without any boundaries. In such a universe, if you travel far enough in one direction, you would eventually loop back to your starting point. The universe could, theoretically, be shaped in such a way that a straight-line journey eventually brings you right back home, like a cosmic version of the classic game of Snake. So when scientists debate whether the universe is infinite or not, they're really debating the fundamental geometry and topology of the universe itself. Is it a flat, endless plane, stretching out to infinity? Or is it a curved, closed shape, more akin to the surface of a sphere? Or could it be something even more exotic and strange, like the surface of a donut, also known as a torus? The answer to this question profoundly shapes our understanding of everything in the cosmos. The universe's true shape ultimately determines whether it's truly infinite, finite, but unbounded, or perhaps something else entirely that we haven't even conceived of yet. Therefore, our quest as cosmologists is to measure and understand this fundamental cosmic yardstick. But the challenge is immense. We can only directly observe a tiny, limited patch of the entire universe. So how do we even begin to tackle such a monumental question, given our limited perspective? To truly grasp the sheer scale and shape of the universe, a realm far beyond our everyday experiences, we must begin with the event that birthed it all, the Big Bang. It serves as the cornerstone of our understanding. 13.8 billion years ago, a truly unfathomable stretch of time. Everything that exists, all the matter and energy we observe today, was compressed into a single infinitely dense point, a singularity, if you will. This wasn't just the beginning of matter, it was the very beginning of space and time themselves. It's a concept that challenges our intuitive understanding. The Big Bang wasn't an explosion space flinging debris outwards. That's a common misconception. It was, and continues to be, the expansion space itself. Imagine the fabric of reality stretching and growing. This expansion, driven by a mysterious force we call dark energy, continues unabated today, as distant galaxies appear to move away from us at incredible speeds, a phenomenon known as redshift. This isn't because we're at some special privileged center of the universe, but because space itself is stretching uniformly everywhere, carrying galaxies along with it. The Big Bang therefore not only gives us a creation story, but also a cosmic age, a timeline for the universe's evolution. This age sets a fundamental limit on what we can observe, defining the boundaries of the observable universe. Light, even traveling at its immense speed from beyond this cosmic horizon, simply hasn't had enough time to reach us since the Big Bang. Consequently, our observable universe forms a sphere, a bubble of space approximately 46.5 billion light-years in radius. However, the Big Bang theory in its current form doesn't definitively answer whether the universe, beyond what we can see, is finite or infinite. It's entirely possible that the universe began as an infinite expanse, stretching endlessly in all directions. Alternatively, it could have started as a finite yet unbounded space, constantly stretching and expanding. Intriguingly, both of these scenarios are consistent with the observational evidence we've gathered so far. To definitively determine the true nature of the universe, its ultimate size and shape, we need to gather even more clues, pushing the boundaries of our observations and theoretical understanding. The Big Bang provides us with our starting point, the initial conditions, but it's certainly not the edge of the map. So, the tantalizing question remains: what mysteries and wonders lie hidden beyond our observable bubble, beyond the reach of our current telescopes? The observable universe is everything we can ever see or measure, a bubble 93 billion light-years across. Inside, there are at least 2 trillion galaxies, each with billions of stars. Yet, this immense region may be just a tiny patch of a much larger, possibly infinite universe. We're like someone on a beach, seeing only a small part of a vast ocean. If the universe is much larger, the laws of physics suggest that patterns must eventually repeat. Somewhere far beyond our horizon there could be another Earth, another you. The key question, is our observable universe all there is, or just a small part of a grander whole? Most cosmologists suspect the universe is much larger than what we can see. The data shows space is incredibly uniform on the largest scales. That uniformity hints we're seeing just a typical patch of a much bigger reality. So, how do we figure out the universe's true shape? The universe's fate and size depend on its shape, its geometry. According to Einstein, mass and energy curve spacetime, so the universe's shape depends on its total density. There are 3 main possibilities: closed, open, and flat. A closed universe curves like a sphere, finite but unbounded. Travel far enough and you return to your starting point. Its gravity would eventually halt expansion and cause a big crunch. An open universe curves like a saddle space, is infinite, expanding forever, growing colder and emptier. A flat universe is balanced at the critical density like an infinite flat sheet, expanding forever but never collapsing. So, which is it? The answer lies in measuring the universe's geometry. Each shape has different implications for infinity. The evidence comes from the oldest light in the cosmos. By studying it, we can determine the universe's true shape. Let's see what the data reveals. The answer is written in the sky itself. To measure the universe's shape, scientists study the cosmic microwave background, the afterglow of the Big Bang. This ancient light, released when the universe was just 380,000 years old, is a baby picture of the cosmos. Tiny temperature fluctuations in the CMB reveal the universe's geometry. Missions like WMAP and Planck mapped these fluctuations with incredible precision. The data shows the universe is flat, to within a 0.4% margin of error. In a flat universe, the largest CMB spots match predictions. In a closed or open universe, they'd appear larger or smaller. The simplest interpretation, a flat universe is infinite, extending forever in all directions. But there's a catch. Our observable patch could just look flat, like a small patch of Earth seems flat, or the universe could have a more complex, donut-like shape that appears flat locally. The evidence is strong but not absolute, so could the universe be flat but finite? A flat universe doesn't have to be infinite. It could be finite and loop back on itself like a cosmic donut. Imagine space as a three-dimensional torus. Travel far enough, and you return to your starting point, possibly from a different direction. Scientists have searched the CMB for repeating patterns that would reveal a finite, looping universe. So far, no such patterns have been found. If the universe is a donut, it must be much larger than our observable bubble. For all practical purposes, it might as well be infinite to us. The donut theory is intriguing but remains unproven. The search continues for signs of a finite, looping cosmos. Until then, infinity remains the leading idea. Why is this question so hard to answer? We're trapped inside the universe, unable to step outside and see its true shape. Our view is limited by the speed of light and the size of the observable universe. Dark matter and dark energy, making up 95% of the cosmos, add to the mystery since we barely understand them. Even our best measurements have margins of error. The universe could be slightly curved on a scale too vast for us to detect. We may never know the true size of the universe with certainty. If it's infinite or just vastly larger than we can see, we can't prove it. Only gather evidence consistent with infinity. Proving there's no edge is impossible. We can only keep searching for signs of curvature or boundaries. Each new discovery brings us closer, but the ultimate answer may always be just out of reach. Still, the quest itself drives us forward. Our best evidence points to a flat, possibly infinite universe, though the case isn't closed. Why does this question matter? It shapes our understanding of reality and our place in it. An infinite universe suggests we're not unique. Our conditions could be replicated countless times. A finite universe makes the cosmos a contained, perhaps comprehensible object. The quest to answer this question drives scientific progress, better telescopes, deeper theories, and new technologies. Understanding dark matter and dark energy could unlock even greater mysteries. The pursuit of knowledge often leads to unexpected benefits. We may never have a final answer, but the journey defines us as a species. We are the cosmos looking back at itself, asking, where does it all end? As long as we keep wondering and searching, we'll keep learning and growing. The universe, whether infinite or not, will always inspire us to explore.